Okay, so now that we defined, first of all, a way to approximate the Q values given with a Monte Carlo approach, and also define some sufficient exploration strategies using a soft policy, we can now define our first reinforcement learning online policy learning algorithm, which is epsilon, which is on policy first visit Monte Carlo control for epsilon soft policies. And this algorithm will guarantee that we converge on pi star eventually, when we start from some arbitrary policy. So we initialize our state and action tabular setting for all of the Q estimations. We initialize our Q estimation arbitrarily, and we set the returns that we will later accumulate several returns by interacting with the environment, and we'll later take the average of these returns for each state and action pair as our Q estimation. So we initialize this as an empty list, and of course we'll populate this later on given some interaction with the environment. And also we set our initial policy as an arbitrary epsilon soft policy over all of the state and action pairs. And then we repeat forever, where we generate an epsilon, an episode using our current policy. And for each state and action pair for a given episode, we collect the G values, the return, and we update the Q estimation for each state action pair based on the average of these returns. And then we update our policy based on these Q estimations. Right, and we repeat this process until we converge to some policy estimate that is converges hopefully eventually on pi star, that will converge on pi star. Okay, so in order to fully understand how this, or to get an understanding of how this algorithm works, let's see an example. Let's see a running example.